Hi guys. So in today's video, we're going to do a couple practice mole problems. I'm going to walk through how to do them just in case you guys are not getting it. So you can see how I would set it up and how I would solve it. So we're going to be using today this mole problems roadmap that I showed in an earlier video. Moles is going to be our pathway of either figuring out grams, where we can convert between the two by using molar mass, because molar mass is in grams per moles. And then we can also use moles to convert to molecules by using Avogadro's number, which we will use as 6.022 times 10 to the 23rd. So the first problem we're going to try to do is how many moles are in 40.3 grams of H2O. And I'm going to encourage you guys to stop the video here, bring out a piece of paper, your calculator, and try to do this on your own. When you think you have the answer, unpause this video, keep watching, and hopefully you get what I get. If not, hopefully my work can show you where you went wrong. So in order to solve this problem, how many moles are in 40.3 grams of water, we're going to be going between grams and moles. If you look at this chart right here, grams to moles, that's just a one step problem. So when we set it up, we're going to make our T-chart, and it's just only got one line here in the middle because we're going to be doing one jump. All right, if you saw my last video, how we do it is in that upper left-hand side, we're going to put what was given. In this case, that's the 40.3 grams of H2O. On the right-hand side, we're going to put what we are looking for, and that is going to be the moles of H2O. So once we've put that in, we can start to fill out the units for the rest of this. We want to make sure that the units are going to cancel out so that we are just left with what we are looking for, which in this case will be moles of H2O. So right underneath moles of H2O, I'm going to be putting grams of H2O so that the grams of H2O will cancel out. Once again, we are left with moles of H2O. Now, if you look at this, moles and grams, this is a conversion factor. This is molar mass. And so I have calculated it here to the side. So if I use the periodic table, I can see that hydrogen has a molar mass of 1.01 grams per mole. We have two of them, so we're going to multiply that by 2. And oxygen has a molar mass of 16.00 grams per mole. There's one of them, so we just add that together, giving us 18.02 grams per mole. Now, that 18.02, remember, goes with the grams, not the mole. That is, molar mass is how many grams of that substance, in this case water, there are in each mole, in 1 mole. So that 18.02 is going to go with the grams. And then the 1 goes with the mole. Now we're going to make sure, yes, that our grams cancel out, giving us with an answer that will have the units of moles of H2O. From here, we're going to just multiply all the numbers that are on top and divide numbers that are on the bottom. Now, when I do this, yes, you can do 40.3 times 1 and then divide it by 18.02. Or you could just do 40.3 and divide it by 18.02. When you do that, you should get a pretty long number, starting with 2.23640. Don't forget to use the correct number of significant figures. We are just multiplying and dividing here. When you multiply and divide significant figures, you are going to go with the one that has the least number of significant figures. In this case, that's the 40.3. There's 3 sig figs. So our answer should also have 3 sig figs. 2.23. However, if you look at that next number after that 3, it's a 6, which means that we are going to round that 3 up to a 4, making 2.24 moles of H2O. And that should have been the answer that you got. Our next problem that we're going to do is how many molecules are in 3.75 grams of sodium oxide. Once again, I'm going to encourage you guys to stop the video here, try to do this yourself. When you're ready, get back on and keep playing this video. So if I take a look at my moles roadmap here, we are going to be going from grams to molecules. That is a two-step jump. We're going to have to go from grams to moles and then moles to molecules. So when we make our, when we make our T-chart, we're going to have to make it a little bit bigger so that we can jump over to moles and then jump over to molecules. But I've set my problem up so that upper left-hand side has what we are given, and the right-hand side, the upper right-hand side, has what we are looking for, which is molecules. Sodium oxide, before I get into this next part and our conversion factors, you do need to figure out the formula for this. This is ionic. There are no prefixes here. Sodium has a charge of 1 + 1. Oxygen has a charge of -2. So in order to make this molecule have a neutral charge, we're going to need to have 2 sodiums and 1 oxygen. So I came up with the formula of Na2O. Hopefully you did too. Anyhow, now we can go ahead and start filling out the units for the rest of this. We are going to put in the conversion factors, right? So grams there would be in the bottom so that they can cancel out. And keep in mind, at the top, we will put moles because we'll be going from grams to moles and then moles to molecules. So yes, moles there will be at the top. And then we're going to put moles underneath molecules so that moles can cancel out. And that way we'll just be given molecules. So looking at that first again, that middle box there, we've got moles and grams. Grams and moles is molar mass. So I've calculated it here, getting 61.98. 2 sodiums, each sodium at 22.99 grams per mole, and 1 oxygen at 16.00 grams per mole, giving us a molar mass of 61.98. Remember, that goes with the grams, and that is to 1 mole. That second number, that is Avogadro's number again. And so Avogadro's number, remember, 6.022 times 10 to the 23rd molecules or atoms in 1 mole. And then just like before, we're going to make sure that our units cancel out and that we are left with molecules. Then we can go multiply everything that's on top, divide everything that's on the bottom, and you should get 3.643514 times 10 to the 22nd. If you have a calculator that has an EE button, I highly recommend using it to calculate. If you don't have that button, so that EE stands for times 10 to the something. If you don't have that button, you are going to have to put that 6.022 times 10 to the 23rd in parentheses. Let me know in the comments if you would like a video on that, or maybe I'll put one up later, and I can show you how you could do these calculations. Anyways, the answer that I got was 3.643514. Looking at significant figures, we would use 3 significant figures because the 3.75 has the lowest amount of significant figures. The other two have 4. That would give us 3.64 times 10 to the 22nd molecules of sodium oxide. Okay, our next one, how many grams are in 4.32 times 10 to the 22nd molecules of hydrogen phosphate? Pause this video, try to work this out yourself before continuing on. Looking at our mole problem guide here, we're going to be going from molecules. So here on the other side this time, 2 moles, 2 grams. It's a 2-step problem again. So here I've put on the left-hand side what we're given. On the right-hand side, what we're going to be looking for, which is grams of H3PO4. This is also an ionic compound. So we need to make sure those charges match up. Hydrogen has a +1 charge, phosphate has a -3 charge. So we need to have 3 hydrogens to match our 1 phosphate. I'm going to go ahead. Remember that our molecules, we need to convert it first to moles, then to grams. So I'm going to put that on top. And then at the bottom, make sure that our units cancel out. Our first, the one in the middle that we're going to be dealing with first, that is moles and molecules. That's Avogadro's number. Remember, 6.022 times 10 to the 23rd goes with molecules, and that is to 1 mole. And then our molar mass, I've calculated it here on the side and got 98.00 grams per mole. That number, remember, goes with grams, and that is per 1 mole. If we multiply everything across, divide everything on the bottom, making sure to put those big numbers, 6.022 times 10 to the 23rd in parentheses, you should end up with 7.030222, which rounds to 3 significant figures because of that first number there. So that would be 7.03 grams of hydrogen phosphate. All right. Next, we're going to do how many molecules are in 48.0 grams of sodium hydroxide. Go ahead, pause the video. When you're ready, join us again. And so looking at this, we're going to be going from, if I can look back again, we're going to be going from grams to molecules. And so that's 2 jumps right there. All right, so going from grams to moles to molecules, putting in those units underneath so that our units will be able to cancel out. Those grams will cancel out there, the moles cancel out there, leaving us with molecules. Grams and moles is molar mass. There's the molar mass right there. And then the next one, molecules and moles, that's Avogadro's number. So 6.022 times 10 to the 23rd molecules in 1 mole. Those grams cancel out, the moles cancel out, leaving us with molecules of sodium hydroxide. And if you do your calculations right, you should get this number. We will round that to 3 sig figs. 48.0 has 3 sig figs, leaving us at 7.23 times 10 to the 23rd because of that 6 after the 2. Okay, I hope you found this walkthrough helpful. Please let me know in the comments, and don't forget to like and subscribe if you found this video helpful. Hope to see you guys again.